Hello everyone. In this video we will see about tactile sensors. First, tactile sensors. A new breakthrough in tactile sensor technology is now commercially available. You can see in this picture. It has implications for robotic touch and for human prosthetics. So this is called as the biotac sensor, which can detect the sensations the same way human fingers do. It can feel pressure, vibration, textures, heat and cold. A soft, flexible fluid filled cover can be worn over a biotac to simulate skin. Yeah. Next, importance of tactile sensors. So when a robot needs to handle objects with its gripper, it's important to know exactly where and how those objects are positioned in its grasp. This helps in preventing slippage, detecting if things are out of place, and recognizing patterns. To do this, the robot can use its vision to see and understand the objects it's holding. Additionally, some robots have a sort of a skin that provides feedback about the objects in their grip, ensuring a secure and accurate hold. The advantages of using tactile sensing over vision system. So tactile sensors have advantages over vision systems because they provide more direct feedback, require less data, are easier to understand, and are durable with a wide range and consistent results. So next, different types of tactile sensors are piezoelectric, piezoresistive, resistive type, capacitive, magnetic, optical, ultrasonic, conductive rubber. So we'll be seeing one by one in detail. So usually the sensing elements, the tactile sensors are array of discrete sensing elements. So it can be binary or continuous one. So first, tactile sensors. So these are sensors located on robotic grippers, typically in the form of small touch-sensitive components. Okay. So these sensors allow the robot to feel and gather information about objects it is gripping or manipulating. This tactile feedback helps the robot in various tasks like object recognition, adjusting grip strength, and ensuring the safety of interactions between the robot and its environment. You could see an array of tactile sensing elements placed at the gripper. And next, array of tactile sensors, when it's combined with thermal imaging, provides a comprehensive way to sense and understand the environment. You could see here tactile sensors can detect physical contact, pressure, and texture, while thermal imaging will capture temperature variations and heat patterns. So, this combination is powerful for applications such as in robotics, where it can help the system respond to both physical interactions and temperature related information. So, next is analog tactile sensors. So it's a flexible tool that gives readings based on the force we use. This measurement can be done through light or a potentiometer, which is like a knob that tells you how much force is being applied. Okay. So next is binary sensors. So you can employ micro switches to identify the objects. So these little switches work by sensing the presence of an object when it comes into contact with them. Okay. So next is proximity rod tactile sensors. So imagine a bunch of thin rods pushed against an object. You could see in the picture. So we can figure out how much each rod moves with a system that detects and interprets these movements. It's a bit like using our eyes, that is vision system, to see how things are positioned and measuring how they shift with something called an LVDT. So shift is like a displacement sensing, okay, which helps us understand both the orientation and movement of the parts. So next is photodetector tactile sensor. So it's a binary type that blocks light when you press down on the rubbery surface. Okay. Next is conductive elastomer tactile sensor. So to make elastomers conductive, additives like carbon black or silica are used. So these are known as the electrically conductive elastomers. Okay, see, when you press on them, their resistance changes. Next is anisotropic conductive rubber tactile sensor. This shows the changes in resistance when you press or deform it. The more pressure you apply, the greater the contact area, which affects its electrical conductivity. Next is pneumatic switch sensor. Hmm. In a computer controlled gripper, each finger has over 100 pneumatic switches. Okay, in this picture you could see. So when inserting something into a hole, the computer calculates the hole's rough position by distributing force across these sensors. I'll show you the picture. Okay, you can see here. These sensors are protected by flexible insulating sheets made of rubber or polyurethane. Okay. These sheets have a thin metal layer attached which is connected to a voltage source. Okay. Next is piezoelectric polymer tactile sensor. Here polyvinyl vinylidene difluoride. This film creates an electric charge when you push on it. Okay. Next is optical tactile sensor. It's this uses the light to detect and measure tactile or touch-based interactions. It typically involves using optical elements to capture changes in light patterns or reflections caused by physical contact or pressure on its surface. Okay, so these sensors are commonly used in applications where precise touch or force measurements are needed, such as robotics and human machine interface. Okay. Next is a resistive tactile sensor. This uses a special element called a piezo-resistive element, okay, which is like a strain gauge. This element alters its electrical resistance when it's stretched or when it is compressed. Okay. Next is capacitive tactile sensor. So this detects and measures tactile interactions or touches using changes in the capacitance. It works by sensing variations in the electrical charge between its conductive layers when an object makes contact with its surface. These sensors are commonly used in touch screens, touch sensitive buttons, and various applications where precise touch or proximity sensing is required. Next is ultrasonic hybrid tactile sensor. This uses a special material called again polyvinylidene fluoride, which generates a response when it's bent or when it is compressed, okay, and vice versa. That is, it's capable of providing fine measurements with 1 millimeter precision and can handle a wide range of pressures from 0.15 psi to 3000 psi. Okay, it works by converting an electrical field into pulses of ultrasonic energy. To make it flexible and efficient, it's equipped with silicon rubber for compliance and reflection. Okay, so that is all about the tactile sensors and some of its types. Thank you.